All right, we're in unit number 6, energy, page 5 of your notes, working through spring potential energy. We just talked about um, Hooke's law, and we used Hooke's law to determine the spring constant of a particular spring, and now we're going to figure out how much energy we can store inside of a spring. So to lead you into that, I've got a rubber band right here. And if I were to, you know how you shoot rubber bands at different people? And so if I were to shoot a rubber band at someone and I wanted to, that sounds awful, inflict as much damage as I possibly can on that person, uh, what would I want to do? Well, what are some factors? And those are kind of the factors that I've got set up right here in this key concept box. So we're looking for two factors that affect the the energy stored in a stretched or compressed spring. Now, I understand that this is not a spring, okay? But you can think of it also as elastic potential energy. They're related. So, so two factors that affect the energy stored in a rubber band. So if I want to inflict as much damage, store up as much energy inside this rubber band, what would I want to do? Well, I'd want to stretch it back as far as I possibly could. And so that would be distance, or in this case, displacement, x, which we talked about with Hooke's law. It's the same x. And then I'd want to have the stiffest rubber band I could get. So I've got two rubber bands here, and you can kind of see the difference here. This one's kind of thicker. This is a little bit thinner. So if I stretch both of these the same amount, the same distance, the one that would be stiffer, okay, this guy here would be able to store more energy than the other guy. So one factor that affects it is going to be x, and the other factor that affects it is k. All right, so if we were to put all those into an equation, we get the equation for elastic potential energy. And I just wrote down kinetic energy. That's not good. So elastic potential energy or spring potential energy is fine. So however it works out, it's going to be actually kind of similar to kinetic energy. It's 1/2 kx squared. And so let's go ahead and run through the units on this. K is going to be newtons over meters, and then x is going to be meters. The meters is squared, so one of those meters goes away, and then I'm left with newtons times meters, which is a joule, which makes sense because if we're dealing with energy, gotta be able to measure it in joules. All right, the next one. So we want to record a third governing equation, which is going to be elastic potential energy, or I'll use spring potential energy in this one. They're related. So 1/2 kx squared. So put that down on your equation sheet if you need to. Stop the video. And then what factor has the greatest effect on spring potential energy? Well, that's the one that's squared, so that'll be the displacement. And that's for the sheer fact that it's squared. All right, in the next video we're going to work on probably the most important law in all of science, and that would be conservation of energy.